I'm Lindsey, the soybean and small grain extension specialist at Ohio State. In 2019 and 2020, I participated in a multi-state project called Boots on the Ground. This project was led by researchers at the University of Wisconsin-Madison and University of Nebraska-Lincoln. This project involved on-farm trials across the North Central region and was funded by the North Central Soybean Research Program. To understand the research trial, I'm first going to back up and discuss another research project we participated in during the 2016 through 2018 growing season. During these years, soybean agronomists across the North Central region distributed a paper survey to farmers to document their soybean yield and management practices. The small box here shows where the data were collected. Each red dot represents one paper survey. These fields were then placed into a growing environment, shown by the colored map here. So, for example, Northern Ohio is mostly this dark green color. We call this Region 1, which is a similar growing environment to Western Michigan here. The rest of Ohio was mostly Region 2, which is this light green color, which includes central, southern Ohio, and then into Indiana. One of the goals of this data set was to examine factors that influenced soybean yield. Across the entire region, North Central region, the management factor that most influenced soybean yield was planting date. Box A here shows that Region 1, again, this is that northern area of Ohio. And here, yield loss was about a half a bushel per acre per day for each day soybeans were planted after the end of April. Box B here shows that central, southern portion of Ohio. Yield was reduced as soybeans were planted later, but by not as much. Here it was about 0.15 bushel per acre per day for each day soybeans were planted after the end of April. After planting date, other important factors included tillage, foliar fungicide and/or insecticide, and artificial drainage. We couldn't separate out the effect of the foliar fungicide and insecticide because these products are often tank mixed and applied together. So after we saw these trends come out of the paper survey, we wanted to take a closer look at these management practices on farm. So we established an on-farm trial that included planting date and foliar fungicide and insecticide application at the R3 growth stage. We weren't able easily to look at tillage and artificial drainage in on-farm research, so that's why we just focused on the planting date and then the foliar products in this study. The on-farm research trial had two treatments. The first we called improved. The improved treatment was to plant soybeans the end of April or early May at 130,000 seeds per acre, and then spray that foliar fungicide and foliar insecticide tank mixed at the R3 growth stage. Our second treatment was the standard system. The standard system was planted about 3 weeks later than the improved system at a higher rate of 160,000 seeds per acre. And then we had no foliar fungicide or foliar insecticide applied. If you want to see more details about the full protocol, it's on my website here, stepupsoy.osu.edu. This is a map that shows our locations in 2019. You can see here in Ohio, we had a very good east to west distribution across the state. These are the results for 2019 across the Midwest region or North Central region. The horizontal axis here shows yield of the reference or yield of the standard treatment. And the vertical axis here shows yield of the improved treatment. Again, the improved treatment was earlier planting, lower seeding rate, and that tank mix of foliar fungicide and insecticide at R3. This red line is the 1-to-1 line. So basically, research trials that were above this line meant yield was greater for the improved treatment. If any trials fell below the red line, it means that yield of that reference or standard treatment, later planting, higher seeding rate, and no foliar application, yielded greater. I circled the Ohio locations here so they would stand out a little bit more. Overall, in Ohio in 2019, there was a yield advantage to that improved treatment. Sometimes it was about 5 bushels per acre. Other times here, this location in particular had a 20 bushel yield advantage with the improved system. At this location, there was a planting date effect for sure, but also they had frog eye leaf spot in their field. So I think that earlier planting combined with having the foliar fungicide application really helped increase soybean yield there. And we did have one location where our standard treatment, the later planting, had a higher yield. And sometimes this can happen, and it's very weather dependent. If soybeans are not receiving enough rainfall between the R3 and R5 growth stage, then yield can be impacted. However, across the entire Midwest, the improved management system had an average yield increase of 5 bushels per acre, which corresponded to an additional profit of $51 per acre. Again, this shows the 2019 results, and this red line is where the break-even point is. So trials that were to the right of this line meant there was a profitability associated with that improved management, which was the majority of the trials. If you're interested in participating in the trial this year, feel free to email me. My contact information is on this slide, or you can contact your county extension educator. For more information on the trial or the full research report, you can find that on my website here. I talk mostly about 2019 data summarized across the Midwest. Mary Griffith is going to get into more details about the 2020 trials conducted here in Ohio. Thank you.